it's Gabrielle, and this video is a sample from Studyclix Boost, our new rapid revision tool. Go to studyclix.ie/boost to find out more.
Now we're looking at independent events. Now what they mean by independent events is that the outcome of one event does not affect the outcome of another event. So if I rolled one dice, it doesn't affect the outcome when I toss a coin. Now that's one of the few definitions that you do need to learn and be able to write out in your Leaving Cert exam. Another and crucial thing that you must know for independent events is this: the probability of A times the probability of B is the probability of A intersection B. If you don't know that, there's not a hope of doing these questions. There's a lid for every pot, and the lid for this pot here for independent events is that. The probability of A times the probability of B is the probability of A intersection B. So practice writing that out again and again and again, because if you don't know it, you'll not be able to do the questions. So let's have a look. They've given me a Venn diagram, and they've given me the probabilities of each of the events. If I added all that up, it should give me 1. Prove that events A and events B are independent. Now, once I see independent, I'm underlining it in the exam, I'm highlighting it, and I'm writing down the formula straight away. So for independent, probability of A times the probability of B, that wee dot just means times, spice it up instead of the multiply sign, times the probability of B is the probability of A intersection B. Now the only place you'll make the mistakes is that you'll rush in, and for the probability of A, you fill in 0.28. But that would just be A only. A is that entire green circle there that we can see in the Venn diagram. So it's 0.28 plus 0.12. And if we add those up, it's like 28 cents and 12 cents, we get 40. So that's 0.4 times our probability of B. Same thing. Don't rush in and say 0.18. That's B only. So we're looking at everything inside that B circle. 0.18 plus 0.12, and we get 0.3. And if they're independent, that will be equal to the probability of A intersection B, which is 0.12. Throw into your calculator now, 0.4 times 0.3. We get 3 over 25. Is that the same? Press the ST button. 0.12. That is lovely. So, throw a wee conclusion in that. Therefore, don't like writing words, so my 3 dots. Therefore, independent. If we ended up with, say, 0.2 on one side is equal to 0.12, they're not equal, we can deduce that they're not independent. So if that question was phrased, are events A and B independent, then we might get different answers. But the way this question was phrased, prove that they're independent, that meant that both sides had to be equal. So, wee thing to be aware of, if they said, are they independent, you might get different answers. But when it says prove that they're independent, we're going to get the same answer.